So the first thing, obviously, that we need to talk about is why is this important? And a lot of these statistics that I mentioned today have come from my discussions as a data strategist with well over 100 chief data officers over the last 12 to 16 months or so. I can tell you for sure, whether through the podcast, through my work, through anywhere, every chief data officer of a large or medium-sized enterprise is speaking about data democratization. They're speaking about citizen data scientists, and they're speaking about these topics because it is hugely important nowadays. But the first thing is why, and firstly, it is because there is this shortage of data scientists in the world today, and we've all heard these statistics. The UK, this is where I'm based in London, by the way. But they released their national artificial intelligence strategy for the next 10 years or so. They released that about a month ago. And they said that in the UK alone, there is a shortage of 110,000 data scientists today. That's increased about 16% from last year. They also said that over the last year, anybody trying to hire data scientists, 69% of them surveyed said it was very difficult to do that. In other countries, Forbes have said that in the US, there's a shortage of 250,000 data scientists. So when we want to scale AI, we're not talking about the largest enterprises. We're speaking about everybody, everywhere, in every geography, in every size industry and company. And if there's this barrier to entry of a shortage of data scientists, or indeed the sort of expense that some of these unicorn data scientists cost, then this is going to be accessible to the few, not the many. That's not what we want. I've also seen that still there's this legacy mindset of a unicorn data scientist. So I know people signed up to DeFi, you have many different backgrounds, you have many different skill sets, and you all together can sort of make up this vision of the unicorn data scientist. And we need to get our minds out of this vision of an isolated one-person team to having AI as a team in itself between different skill sets coming together to solve common challenges. I like this diagram on the right side of the screen because it shows the ingredients to make this unicorn data science concept. The first one is computer science skills. So I know that's what a lot of you learn at DeFi, the Python and the OR and these coding skills. Math and statistical knowledge is also critically important. And the final element is domain knowledge. And that's something that is often forgotten is hugely important. And this brings me back onto the left-hand side of the screen, which says the second point of why to democratize artificial intelligence and data science is because we have crucial domain expertise in every one of our companies that have been built up over many years that are not being used to forward this agenda. Again, let's take engineering. In the EU, we have 3 million mechanical engineers. None of them, or very few of them, are doing data science today. That's a huge growth, a huge scale of people that we could be using. Gartner has said that the citizen data science market, so that person who has their skills in one area, but with low-code technology can bridge into becoming more data savvy, that market for the citizen data scientist is increasing 5 times the rate of the expert data scientist. So in the short term, these domain experts can take some of that bottleneck of resources out, but also in the long term. It's all about collaboration, as you see today, but in the long term, it's the domain experts that should be making the decisions with the help of data science and with the help of the expert data scientists. The other reason to democratize artificial intelligence is because expert data scientists, like many of you on the line, are not being used to your fullest potential. How many times have I heard that a data scientist is spending 80% of their time with no value add, with doing data preparation, doing cleansing of the data, ETL, these types of components of a machine learning workflow which don't add value whatsoever. That is going to cause your data scientist to churn. If you're not happy, if you're not doing your challenging projects, you're not going to stay in that company. And as you'll see, we need both. We need the experts, we need the citizens. And so democratizing artificial intelligence to the wider population means everybody can focus on what they're good at. The citizen data scientists can do the data mining, do the descriptive statistics, do the basic modeling without having to go to IT, so fast decision-making, agility, and the expert data scientists can do the custom model development, can do the more complex applications. with all of this, the fourth point here is about collaboration. I hear a lot about companies saying, oh, but what area should I be doing AI? What use cases should I be doing? Can you give me some advice? And I think with the right training, the right mentality, the right enablement, that conversation won't happen anymore, because you're going to have your business people and your data people going to be collaborating. For me, there's no such thing as an AI use case. It's a business use case amplified by artificial intelligence. And I've seen it myself with data democratization, and a lot of enterprises in Europe. The use cases they're doing are niche, they're novel, they're great, they're adding value every single day. They're not predictive maintenance or fault detection, these ones that you hear a lot about. They're very particular things to very particular sectors. But companies will not invest if there's not immediate return on investment. So the final point here is data democratization is not about saving on people's costs, not at all. It's about making return on investment. Because if you get more people involved in this, doing more use cases, you're going to get more return on investment. I think it was Fortune that said this strategy will increase the amount of use cases you can do by 10 times. And one of my partners, Jaguar Land Rover in the UK, they've said, their head of center of excellence said to me that every use case they do is a 96 times the return on investment. So 10 by 96, and you've got a big return on investment there. Also, McKinsey said those that scale AI between now and 2030 will double their cash flow through democratization, and those that don't will see their cash flow reduced by 20%. So the statistics don't lie. This is an important topic, and this is why you need to do it. As I said in the introduction, I don't want us to go into this with sort of blinkers on and think this is the first time we've ever democratized something. That's not the case. We've lived over the last 50 years or so in a world that's increasingly digitized. We're democratizing things all the time. Currently, we're in the age of artificial intelligence, and I have no doubt over the next decade or two, we'll be democratizing that too. What this slide shows you now is the evolution of design and engineering within the sort of automotive sector, let's say. So any car you've ever driven, any plane you've ever taken on holidays, any golf club you've ever hit, tennis racket you've ever played with, any sort of physical product that you use, an iPhone, a Samsung, a medical device, they're not just designed by physical testing and trial and error. They're designed digitally. The engineering sector is incredibly digitized. There's a digital twin of all of these products that they're applying different stresses to optimize the design and engineering of these components. In the 60s, all of this, well, this was sort of a budding field in the 1960s. It was done through code in universities that were developing Python modules, more or less, to simulate what might happen to the bonnet of the car if it crashed into a bus or a truck or another car or into the wall. In the 70s, research institutions like NASA got quite involved and started to productionize some of these use cases. In the 80s, you started to see, and in the 90s, companies come out of the woodwork and be founded to try build a graphical user interface on top of this code so that we could start to scale this to many other people in the organization. Because when it's just in code, then it's very difficult for too many people to use it. It requires a lot of training. And if we can get the coders to focus on what they're good at, but get other people to use their domain expertise to forward the agenda, that's what you're looking for. And this slide again shows that, you see that bar going across, which is the coding and the developer experts, the people that are building all of these. And then above that, you see the simulation domain expertise. And you're seeing that the coding developer expertise, that remains constant. It is always needed. It is so important. But that the simulation domain expertise increases. And these people are people that are building models without writing code whatsoever. And then when new innovations like product design come out, then you can start this with no simulation background at all. And again, what I'm trying to say to you is this democratization is common. It always starts in code. Data started in code as well. Building models in a range of different coding languages, that will always be important. But what also is important is this drag and drop, a low code technology to democratize it and get more people involved. Again, look at the first computers. Could everybody have used those first computers? Absolutely not. Can everybody use computers nowadays? Absolutely. Even kids, toddlers I've seen in restaurants, 2-year-olds using iPhones and iPads. And that's because of the evolution of graphical user interfaces and the sort of usability of technology and the democratization of it. So again, I think when we're starting to do this in our organizations, and this is what we at Altair are seeing, is to scale this out, we need the best of both worlds. We need a hub and spoke model. We need centralized data expertise, but we also need a lot of spokes, which is these domain experts in their individual business units, be it in HR or finance or marketing or engineering or manufacturing, let's say, being able to run models, run use cases very quickly. So again, if we go to the simulation world, this world that is so digitalized right now, nobody in their right mind would code a simulation model from start to finish because it just doesn't make sense anymore, because there are so much graphical user interfaces. You can build a lot of that first part, and the coders can then come in and can do the model validation, can run the accuracy checks, can do all of these different types of things. So again, in simulation, within a typical center of excellence, you'll have the methods development team. So here you can sort of think of your unicorn data scientists from that first slide, the people that have domain expertise and they have coding expertise. They're your specialist developers, let's say. They're the ones that do all the training from everybody below them. They're the ones that define best practices. They're the ones that do the process management. They're the ones that really control the types of technology that the whole organization will use. They're the ones that do the evolution or the evaluation of technology. And below them, then you have the simulation team. So again, if we're thinking about data, here you have the data science team, the coders, the people potentially like yourselves or potentially yourselves are more the citizen data scientists, the people that sits below them, the people with very limited simulation expertise, or again, in this case, very little data expertise. And you need to define which role you're going to play in these organizations when you enter these organizations, or where you play today, because each and every role is unbelievably important, but you need to define where you sit, because there does need to be this sort of tiered approach, in my opinion. Again, this hub and spoke model means that you have the centralized economies of scale and structure, and the hub needs to sort of govern data as an asset. They need to have governance, it's so important, lineage, control, and they need to define the self-service tools that the rest of the team can use then. So the rest of the team know that the data they're working on is of high quality. It's not garbage data, it's good quality data. They've had the best practices, they've had the training from the people above them, and they can then do all of their use cases at a fast speed, while the hub again validates the models, ensures that there's no bias in the models, ensure that they've been created efficiently. So that is the structure that I see Center of Excellence is starting to implement from a data perspective now as well. So at the bottom, again, these sort of casual users that have their general work to do, whether it's payroll or whether it's marketing, and they're sort of part-time users of data science. Above them, full-time users of machine learning, and above them, again, these people that have the domain expertise, the math and statistical knowledge, as well as the coding knowledge. Again, why is that important? And again, this is taking from my experience within the simulation, the engineering world, where we've democratized simulation beforehand. It's because that methods team, the team at the very top, they're the people that have the most innovation. They're the people that have been in here the longest. They're the people that can come up with the most creative solutions. But they're also the people that are the hardest to find. And you'll be lucky if you find 10 of these people in the world for your chosen organization. The simulation team, or again, this data science team, they have much less innovation per member, but still quite a bit. And then below them, again, the design team, the citizen data scientists, they have less innovation per member again, because generally they're part-time users. But again, if you start to multiply that by the amount of resources that there are for that methods team, yes, there's a lot of innovation per member, but there's very few of them. For the simulation or data science team, there's quite a bit of innovation per member, but there also, as you see at the start, there's a shortage of them. There are great conversion courses like DeFi are doing. Again, the UK government has 2,500 master's conversion courses at the moment, but they'll never be enough to scale to all of the different domains. And I'll talk through some use cases later on. And again, finally, the design team, the citizen data science team, there are so many of them. There are 3 million mechanical engineers in the EU alone. Every industry have their own domain experts. It wouldn't have existed without them. So you see the innovation per team is, again, much higher within that design, that citizen data science team. And if you translate to success, you see that if you combine the citizen data scientist with the data scientist, the innovation you're getting is about 175 times the innovation you're getting with the methods team. And this is the same in simulation as it is within data science and artificial intelligence. And the example I'm talking you through is an automotive example. And you can see here that in 1991, a car took 60 months to produce. In 1998, 50 months. 2012, 40 months. In 2020, 20 months. So the life cycle of the design, manufacture, distribution of a car have reduced by 3 in the last under 30 years. And that's again because you've got more people doing more things and helping out more. And this is the message of democratization. This is the same thing we need to follow with the data science perspective. And I hope this makes a lot of sense to you. So as you see, the same story exists with data. And we need to start thinking, what do we as a community, as myself, as DeFi, as wherever you're joining from, what do we need to help to democratize? The first thing, well, these are the 5 steps, I believe. The first thing that we need to democratize to achieve these goals is data. People struggle to evaluate self-service and low-code tools because they don't have the data at their fingertips. We need much more publicly accessible data sets, governed data sets and ungoverned data sets. You saw with COVID-19, there was a lot of publicly available data on the spread of the virus. And through that, we had a lot of people become educated in this world. They understood, oh, I understand now when governments prescribe to wear masks or to do social distancing, is because I can see with the data that it's going higher and higher and hospital beds are decreasing and decreasing in availability. So this democratization of data has all of a sudden democratized sort of understanding of this world. And that's something that we need more of today, more publicly accessible, open data sets. Second thing we need to democratize is algorithms, and open source code repositories like GitHub are sort of the first step in this process. We need more of them. We need more interaction with these democratized algorithms. The third thing is compute, and I think this is important because this was a barrier to entry as well in terms of hardware, in terms of CPUs and GPUs. And the beauty is that cloud computing has started to democratize this. The big clouds in Europe anyways, AWS, GCP, and Azure. In APAC, you have a bit more of Oracle, you have a bit of Alibaba Cloud as well. But you have obviously a pay per sort of usage model. And this is allowing people anywhere in the world with their own different desktops and computers to start to build models. Of course, we don't want it to be too monopolized, let's say, to some of these big cloud vendors. And there are some concerns now that it is becoming too monopolized, and the UK government are releasing a white paper on this in the next few months. The US are about to launch a National Institute for AI Research, where they're giving free compute resources to academics and researchers, as well as accessible data sets. So democratizing compute is very important, and it's something we might become challenged on recently. The compute requirements for AI, according to a statistic I read recently, is increasing, well, it's doubling every 3 to 4 months. This is, of course, becoming more and more compute intensive. We have to be careful of that as well. Democratizing models, AutoML is the most obvious innovation we've had in this space. Most vendors are introducing this into their platforms. Some have grown up with AutoML from day one, like Data Robot, let's say. AutoML is great, but I also want to say that democratizing AI doesn't just mean that people can press a button and they can do AI and that's done. People need to understand the output. People need to understand the input. People need to be able to explain their results to stakeholders, to regulators, to shareholders. And when using AutoML, we need to democratize that first, but we also need to democratize being able to lift the hood of AutoML, see what's happening underneath, and that's something that doesn't happen every time. And ethics, as I said at the start, in the EU, we've released the AI Act, which is was the first regulation in the world on artificial intelligence, and this speaks quite a bit to explainability requirements and being able to submit reasonings for your results. And so when democratizing models and AutoML, also be careful of ensuring it's a glass box, not a black box. And finally then services, and again, DeFi play a huge role in really all of these parts, but in services, DeFi, Kaggle, we have these marketplaces now for data, for algorithms, for models, for compute. We have competitions. We have a growing gig economy now as well that organizations can dip into for some help, some services, some expertise. And this needs to be continuously democratized as well and scaled so that people all around the world can use expertise from all around the world. So with all of this push into democratization, you will see some job roles changing slightly. You will see new job roles. What I want to say at the start, on the left, you have the expert data scientists. For me, they're more important than ever before. Their role will change slightly because we do hope and expect them to spend less time on that manual data entry, data prep, this part of the world. We want them to focus on the custom model development. We want them to focus on sort of model validation from some of the other users in this pipeline. Talking about other users, you have data buddies. Data translators are also within organizations now that can translate things between the experts and the citizens, the data people and the business people. These data buddies, again, should work hand in hand with citizen data scientists, should educate them, should train them. And then you have the citizen data scientists. And we'll speak a little bit more about what that is or who that is. But what I did want to say is I spoke to Richard Benjamins recently, who is the chief data and artificial intelligence strategist at Telefonica, the huge telecommunications giant. He said for a citizen data scientist, they need the 4 C's in the future. And this really makes it clear for me. They need creative thinking, they need critical thinking, they need collaborative skills, and they need communicative skills. So communication, collaboration, critical and creative thinking. That's what the citizen data scientist needs. They need to be able to delve into a challenge to find a hypothesis. And we'll go into the type of person they are later. Subject matter experts, DevOps and IT, leadership, of course, all incredibly important. You see here the range of innovations and tools and use cases in this world. And to lump all of that on an isolated data scientist or isolated data scientist teams is not scalable or sustainable. We'll have more jobs in this area, more roles, changing roles. Everybody is as important as the next. And collaboration wins. So to get a bit more technical in terms of how you could divide it up, what we see a lot is that on this slide, the CDS stands for the citizen data scientist, and the EDS stands for the expert data scientist. So, and again, you know, it's not black and white. There's not a citizen data scientist, an expert data scientist. There's a citizen, there's a data buddy, there's a data translator, there's a junior data scientist, there's an expert data scientist, there's that, you know, methods developer. But the citizen data scientist or the junior data scientist, for instance, can obviously do all of the ingesting and connecting. That's something that if you're spending your good experts, data scientists doing, is not creating a lot of value. So fortunately now we have tools in the marketplace. I'm sure you know a few of them. Please ask me if you don't, but that can connect to data sources, be that structured data sources, semi-structured, unstructured like images, real-time or static. Pull that information, structure that information into rows and columns, maybe store that information in a data lake. Then the prep of that information is quite important. And this is, I think, where citizen data scientists can really start to play quite a bit, to prepare it according to what the model needs, to know sort of what features or variables are most important. And moving then to the exploration of the data, this is so important. And as I said earlier, data science can mean different things to different people. And if a citizen data scientist can build a decision tree, a basic model, can build, reporting, descriptive statistics, mean, max, median, these types of things, they can be very happy with as well. So it can mean different things, but this data exploration, data mining, finding insights in data through graphics and visuals, can really accelerate their jobs, accelerate their insights. For the building models, again, the general ones can be built by a citizen data scientist, AutoML, for instance, but the experts can then build the deep learning models, the more complex models. For packaging models and starting to run them into production, starting to deploy them into live systems, all of that will be done by the experts with the help of generally some IT people. And that's important because, again, the use cases need to come from the business. They can do the start of it, and the experts can come in to deploy those systems, to productionize these systems, to ensure these systems are scalable, are explainable, are accurate, are based on good data, defining those best practices. We're getting more people involved so we can build more use cases. And how I think this all comes together is this quotation from Ming Tang. Ming is the Chief Data and Analytics Officer at the NHS, which is the National Health Service in the UK. And again, she was on the Future Says podcast recently. But if she said if we are looking at machine learning to provide solutions for clinicians, the last step has to be the clinician, not the machine. And this makes so much sense. The clinician knows the status quo. They know how they need to provide the answers. They know what makes sense. But with sort of self-service tools, they can accelerate their insights, they can improve their insights. And with collaborative tools, they can use some of these expert data scientists to feed them the information, but to know how to do that storytelling, to know how to provide that answer, because they are the ones that's their job. I mean, it's not the data scientist's job to provide the solution to the clinician, or to the end patient. Let's say it's to provide it to the clinician, to put a story on top, who thereafter puts it to the patient. And we've seen so many times this go wrong, that we're using the algorithm as the gospel truth, and putting that then to production and starting to see bad results. Apple Card, in tandem with Goldman Sachs, their credit scores were far more favorable to men than women. Again, obviously terrible. We've seen racial discrimination by taking the algorithm as truth. In the UK this year or last year, we had they built an algorithm to decide the exam results because they couldn't do the exams because of the pandemic. And the results were, the algorithm decided results 60% lower than all of the teachers had graded them, and that it favored private school students over public school students. And there was complete uproar, there was protests, there was a lot of cursing, there was a lot of traffic jams, there was complete bedlam really in the UK after that, because it wasn't fair, it wasn't just. And again, if they had provided this to the teacher instead, the teacher could have came to a collaborative decision to say, no, look, this is unfair, this is unjust, we need to massage this message, we need to improve this model. So that's this collaborative effort between the data and the decision makers, the domain experts. So I wanted to then go through a couple of examples that I've seen in the last year, or the sorts of projects I've worked on in the last year. Some of these big brand names, I'm sure you know, some you don't. So I'll briefly introduce Ford. Of course, they've transformed the automotive industry with the Model T over the years, and now they're trying to transform AI through democratizing it to many different business units. They have a strategy where they have a lot of expert data scientists, professional data scientists, and they are tasked with solving the complex challenges like autonomous vehicles, connected cars, these types of use cases. But they know that there's a lot of business as usual efficiencies that they could develop, and that the best people for that are the people that have been in these business units for many years, the domain experts, or as they're starting to call them now, the citizen data scientists. What Ford have done is to train over 1,000 of these citizen data scientists in the last year, just in the US alone, in different plants. A sort of smaller scale as what you'll hear from Rolls-Royce and others in this presentation. But that was their strategy, and a project we worked with them on was in their stamping mills. So the process of stamping a part of the car with different dyes is a complex process. It's a manual process. It's a time-consuming process. It's an error-prone process. Stamping mills in general expect about a 60% material utilization. So 40% is just completely wasted through this trial and error. So you want to combine the optimal body part with the best material usage. And that's the challenge that Ford presented to us. They said, this is trial and error. This is, engineers that are aging, that are close to retirement, that still have to do this. We have a data set of all the successful and unsuccessful runs, who did them. And we want to see, can we automate that? Can we build an algorithm that can predict the best stamping approach, hot stamping, transfer stamping, any of these types of things that could predict the optimal type of approach as often as possible. And that's what we built. And actually what we built, when we presented it to them a week after, they sort of laughed at us and they said, that's funny, we came to the same answer. And I said, well, how did you get to that answer then? And why did you ask us to do the same project? And I said, well, it took us about 6 months and a lot of help from a lot of external data science people to build this model in Python. And when they presented it to us, it made no sense. There was no explainability. When different variables had to change, we needed to tweak the model, and we didn't have that experience and expertise. So what you presented to us within a week shows how efficiently we can build models and how we can quickly understand models. And again, with this use case, they're now improving the uptime by 3 times, and they're reducing their material usage by half. So a big success there from Ford, and now training a lot more citizen data scientists. Rolls-Royce, another massive name within industry. They've gone through a huge cultural transformation in the last couple of years. They set up a new entity called the R² Data Labs, global entity. There they've logged 78,000 hours of training over the last couple of years. And they've developed training materials, courses, ranging from tutorials, 20-minute videos on what is data prep, what is data mining, to fully fledged sort of certification courses. There, they've actually managed to train 20,000 engineers in the last 2 years. So massively successful, and they're training people that have no data science expertise, training them into expert data scientists with Python and R experience for those ones that want to go that direction, or the ones that don't have the mentality to go full way to really be more the citizens that have enough knowledge of the business use case and enough knowledge of self-service tools to build the use case. And again, what we're working with them on is jet engine design. So these are their aero jet engines, all the engines they put into their jets, propulsion engines. It's what is their secret sauce, what they make most of their revenue on. Again, building these things takes about 10 years. They're huge things, requires a lot of simulation for the engineering. It then requires a lot of testing. In the testing process, they will throw gallons and gallons and gallons of water through it, 6 gallons every minute of water through this thing. They'll start, they'll put it in 30 degree, minus 30, minus 60 degree starts, really test it almost to destruction. What they wanted to do was equip these engineers with artificial intelligence to accelerate the process of designing these engines. Of course, these engineers weren't trained on AI. They were trained to use their institutional knowledge to combine, to create 3D models of the engine and its parts, and ensure the designs don't defy the laws of physics, let's say. Once they'd done that design, they would build physical prototypes, they'd put sensors on the prototypes, and they'd monitor these sensors. And they'd then put it to production, and they would have a lot of in-service and production data, etc. But where they were making the decisions was in the design phase, where there was the least amount of data. So what they wanted to do was to use previous iterations, previous runs, previous engines, to be able to predict in the design stage what is the optimal design, predict root cause failures, predict anomalies, and optimize the design of these engines, and do it in a couple of years rather than 10 years. And they've been hugely successful at that now as well, and scaling that to many other use cases. And again, what you'll see later is what companies are doing. They're picking one use case, prove the concept, just like any proof of concept, prove it on one, start small, and then scale it fast. Do 2 more, 3 more, use the ROI you build in the first project to spur on the next ones until you're going to, tens, hundreds of use cases every month, every year, depending on the size of the organization. Moving on then, Mabe, you might be less familiar with. They make home appliances, smart home appliances, like ovens and fridges and washing machines. And again, they were developing a new washing machine. They were putting 20 sensors on the washing machine for noise, vibration, water, pressure, temperature, these types of metrics. And they wanted to see, could they optimize these washing machines, the next generation of washing machines, by better understanding the health of existing ones in the field, better predict when these machines may fail, better predict the optimal usage, better predict customer satisfaction. And again, they were able to do this with drag and drop tools that they didn't need to go out and pick up expertise from elsewhere. And Mabe, they're not a Rolls Royce, they're not a Ford. They can't hire 100 of data scientists. What they can do, they can use the people already in the company, upskill them on these tools, and start to do really, really advanced predictive maintenance use cases. The final one here then is Gruppo Cimbali. They're even smaller again. They're about maybe 200 people based in Italy, and they make espresso making machines. So hopefully everybody is enjoying this, maybe has a coffee with them. I'm looking forward to one after this presentation, but maybe you even have a Gruppo Cimbali machine. Generally, they're used in restaurants, though, and cafes and bars. Unbeknownst to many, these machines are really complex. They're really technologically advanced. They have mechatronics inside, they have embedded sensors, they've thermodynamics, they've fluid dynamics, a lot of interconnected systems here to produce an output. They're also used in very harsh conditions. So to monitor them is very important. They can fail quite often because they are used in such harsh environments. Again, what Gruppo Cimbali wanted to do was to actually build a digital twin. And that's what you see on the image on the right-hand side of the screen. A digital twin of these coffee machines to see what is the optimal energy efficiency. How can we hook up these systems? To see, can they run more design iterations in a shorter space of time? To see, can they run things virtually rather than physically? So rather than produce a physical prototype that takes a long time, that is costly, can they run this? Can they do predictive maintenance on the virtual model so they can optimize future models? And again, these are their mechanical engineers doing these use cases. They've got the help in this instance from, people like ourselves that have data scientists already, potentially people like DeFi that have a group of data scientists ready to work on a project. And sometimes in the smaller organizations, as they scale up, that's what they might do. Train the citizen data scientists, but to have that oversight from the data scientist expertise, either internally if they can, or externally. And again, the results here, I think their new coffee machine, it produced 30% faster than the previous ones, and the energy efficiency is 20% better. So really good, effective results here. Again, another area that we see a lot of citizen data scientists working in is within warranty, because it is such a huge topic for any producer of any consumer good, really. This slide sort of shows it from an automotive context, where, of course, you have a failure that occurs on the part of the car, or you then have the different threads. And once the failure occurs, if it's within warranty, you bring it to the local dealer, you explain the fix, they collect that data, and they then send that data back to the OEM. And again, if I was to further explain the scale of this challenge, 2 to 5% of every automotive's revenue is spent on warranty claims. McKinsey say it's about an average of £100 million a year spent on warranty, but we're working with a client who spent £1 billion per year on paying out of warranty claims, which is 5% of their revenue. And they're one of the biggest automotive companies in the world. So it's a hugely important challenge to solve. And it's also a hugely complex one. The start of it is pretty basic. So as I said, that's how you load data. The problem is a lot of these dealers, they'll send the data in a multitude of formats. Excel, PDF, text, over the web, many different types of formats. They'll structure it in different ways, rows and columns, different column headers. Oftentimes they'll have different colloquialisms in there. So they'll put different definitions for different words. There's also a linguistic challenge. Big automotive OEMs sell their cars to many geographies. Of course, these warranty claims are going to be coming in English, in Mandarin, in French, in German, in all these different types of languages. And so to do this data preparation is quite complex. And again, to go back to the previous slide, can often take about 80% of the time of data scientists, so that there's very little time to actually find some insights from this data. But anyways, once you do the data preparation, the machine learning is to group and size these warranty claims. And oftentimes it's on an ORFM scale, so recency, frequency, and monetary value. And oftentimes this, again, can be done, this blue is the machine learning, this can be done by the expert data scientists, the people that can build very efficient neural networks and classification models that will always be sort of outside the citizen data scientists or the engineer's remit. You'll then have early warning and issue prioritization. This is a mix of machine learning and visualization. So early warning systems will generally be a dashboard of sorts, which will flag, there'll be an alarm, there'll be a burning red light that tells somebody somewhere to do something. And again, this can generally be built, we see, by the expert data scientist, but the visualization aspect is done by the citizen data scientist, because they understand what's going on, and now they have this visual element of things that they can iterate and change things when it matters. And that's really important. But then above you have some of these commercial applications within warranty: fraud detection, which claims are fraudulent, cost prediction, claims prediction, recall optimization. Should we recall? Should we not recall? Just last year, BMW recalled 400,000 cars in the UK. And these algorithms, they don't require a lot of domain expertise. They're standard algorithms across many sectors. Fraud, for instance, is very standard. And these can be done by expert data scientists, maybe a mix of citizen data scientists, but the things that expert data scientists can really excel at. When it goes into the engineering, though, that's when you start to converge in the engineering space who have expertise in, as we spoke about earlier, this sort of simulation world. So root cause analysis: where did this issue come from? What plant did it come from? What operator did it come from? What component did it come from? What time did it come from? Why did it come? All this root cause analysis is a mixture of machine learning, of visualization, and also of simulation, as is design modification, as is process improvement. And again, this is because of this slide, which I know is sort of difficult to look at initially, but for me, it's really exciting because it's a convergence of so many of these worlds where you have the physical car, the physical twin, generally one born every minute, a car produced every minute. When a warranty claim comes in, when you're doing this design optimization, this root cause analysis, you can test scenarios on the virtual twin. And this is something that the domain specialists, the engineers, the mechanical engineers, the electronic engineers can start to do, again, with low-code tools. So what you sort of see here is a world of use cases, of applications, of different areas where citizen data scientists work, of where expert data scientists work, where they work together. And that's what's quite exciting. So how to start? And I've only maybe about 5 minutes left. So how do you actually identify these people? And I'd like you to think yourselves now as well. If are you a citizen data scientist? Are you an expert data scientist? Are you a junior data scientist? Where do you fit into this sort of workflow? For the citizen data scientists, who do we find are the optimal people? Generally, it's somebody that's motivated enough to attend a presentation on a Sunday, let's say. But they're young, they're hungry, they want to succeed, they want to learn these tools. They understand that by mastering these tools, they can progress their careers. They're also confident people. They're able to go to bat to justify the business value. So they're confident in what they're doing, and they can preach that confidence to senior management to say, we need to do this, and this is the reason. They also need a contextualized view of the organization and business use cases. They need to understand the domain they're operating in. They need to understand what would add value, and again, use these self-service tools to get to that value. But what I do want to say is that they need an analytical mind. And there's some people out there that says anybody in the world can be a citizen data scientist. To some degree, that's true, but I'd say the better ones, the ones that are going to certainly be the initial ones, the champion ones, they're going to be ones that generally have an analytical mind. They use Excel, they use SQL, they are learning Python maybe, they're learning OR, they're maybe in the early stage doing some of the DeFi boot camps, but they've got proven application of using these techniques. So they don't need to know what a linear or a logistic regression is necessarily, but they do need to know when a model overfits, for example. So they need to have some sort of analytical expertise. And they also need to be a good communicator. A lot of the hard technical graft that goes into building models can quickly evaporate if you can't explain what you've built. And that's an issue I see for a lot of data scientists and even citizen data scientists. They need to improve their communication skills. I mean, we even saw Mark Zuckerberg try to explain Facebook, and not the metaverse, but Facebook, let's say, a year ago, was it, in Congress, and he struggled to make people understand. So we need to be able to be a good communicator, to give the right information to the right people at the right time, and to pretty much storytell. And again, the components for storytelling: audience, know your audience, know who you're presenting your data science insights to, know the reason. Why did you get behind this project? Because we're spending $1 billion a year on warranty claims. Anecdotes, related to Moneyball, related to some movie, related to something bite-sized that people can understand. Analysis, present the results. Don't present lines and lines of code. That doesn't excite anybody. Present it in a visual dashboard. Present it in a visual decision tree. Present it in a nice, easy to understand and digest way. And conclusions. Why does that matter? What achievements did we have? We reduced energy efficiency by 20%. We accelerated testing by 30%. These are the storytelling elements that every citizen data scientist needs to have. And again, you don't need to have hundreds of citizen data scientists. Sometimes one is enough to get an organization off the ground, to start to convince more and more and more, until, by virtue of just succession, you have many more. Again, another person that I spoke to recently, Antti Milamaki, He's the head of artificial intelligence at OP Financial Group, which is the largest banking group in Finland. And he said that the next generation data scientists will go from a geek to an ethically aware domain expert. That's the sort of merging of the worlds I think that's happening. And he himself, over the last 6 months, has launched a big citizen data scientist drive. He's done, technical lunch and learns, Q&A sessions, workshops, trainings, and he expected in the first half of 2021 to enthuse 10, 20 people. 600 people attended and interacted with a lot of these sessions. So he's completely convinced by this. Thomas Berngruber, who's the head of data analytics at Jyske Bank, which is the biggest bank in Denmark, he said, we prioritize problem solving, including highly developed heuristic and deductive reasoning skills above anything else. So that's this sort of, what is the next generation data scientist, the citizen data scientist? These are the sort of skills that you need. We spoke a little bit about already the starting small and the scaling fast. 80 to 85% of companies are still at POC stage. Some are even at PowerPoint stage. You need to get out of that. You need to take a use case that you can solve in weeks, not years. It needs to be valuable enough that you'll get buy-in. It needs to be feasible enough that you can do it quickly. In terms of what ones to start, anything that's mundane, time-consuming, error-prone, like the use cases I mentioned at Ford, let's say, and Rolls-Royce. Look to competitors. What are other people doing for their use cases? Speak to the business domains, but also, don't wait to scale. When you see success, scale it, because you'll learn from this trial and error as well. And you need to reward success and don't punish failure. So long as you're learning, you're not failing. And there is a sort of mentality of experimentation that is needed when starting off as a citizen data scientist, or when starting out to learn Python, to learn or through D5's workshops. Errol Kudemeister, who's the head of AI at H&M, he said to me recently that, again, they don't treat their projects as research projects with long timelines. They treat them as something that they should see value of tomorrow. Expectations and change management is so important. You see here the data visualization is beautiful, but don't forget that there's a lot that goes into it. Building a data warehouse, data cleaning, ETL, business requirements. Gartner said 1 in 5 AI projects are successful, so that's not enough. And I'm convinced that oftentimes that's down to expectations, poor expectation management. You need to define upfront what your goals are, what data you have, what resources you have, what quality your information is, and put realistic success criteria in place and demystify AI and what you're trying to achieve. I attended the Gartner conference recently, and I really like these 2 slides about change management. There will be resistance to change in the world. There always is. In the simulation world, there was as well. You're going to have people that can't or won't run, won't do it at all. You're going to have the walkers who will wait and see, is this successful? You're going to have the joggers who are considering it, but will wait to see what the runners do. The early adopters, the first people on board, that are those champion citizen data scientists with the motivation and the hunger. That's normal. Spend most of your time with the runners and gradually move down, because the runners will motivate the ones below them. And again, to relate this to 2021 context, quarantine people that won't or can't run, because they're not worth your time today. Focus on the other ones. The expert, focus on coaching. The practitioner, focus on training. And the learner, focus on awareness and education. As regards education, training, and coaching, the UK government, to get over this gap, there's 2,500 masters conversion courses now. There's boot camps. The work that DeFi are doing is absolutely brilliant. And all of these external resources will be a big help in developing the data literacy of workforces. When you're in them or as you enter them, you should be aware of this. And I think companies need to take a more systematic approach, and they're starting to what their data maturity is. when a chief data officer is appointed, they should build a questionnaire 1 to 5 on responses, on the skill set of people, the data they have access to, the quality of the data they think, how often they rely on data to make decisions. These types of data maturity assessments to get this common baseline of understanding, and then create a learning curriculum, use DeFi as help, have regular assessment points, have contests, join DeFi's boot camps, do hackathons, join Kaggle, you might even get rewards. Have a data buddy as a mentor, and this goes both ways. Have the citizen data scientists or the junior data scientists match up with, have the citizen data scientist match up with a data scientist, an expert data scientist, and have the expert data scientist match up with some of the DNA leaders, let's say, so that you've got this collaboration, you've got people learning from each other. 10% can be classroom learning, 20% can be social learning on the job, and 70% should be 20% should be social learning and 70% should be on the job learning. And that's how you could sort of develop a lot of these citizen data scientists. Capgemini, they have an AI academy where they've trained 60,000 people in the last 2 years. In year 1, they trained 10,000 people, and it was so successful that in the last 2 years, there's been 60,000 people trained. And they have a great system of going from a cadet to a genie, to a guru, to an expert, and different sort of certifications depending on where they are on their data literacy journey. And it's great. And we need to develop these fusion skills in organizations, but also I think in governments, we need to start, and we're starting to see that Singapore have a skills credit, UK government have something similar as well. What Errol said at H&M, the T-shaped profile is what we're looking for. Expertise in one element and sort of a parallel knowledge of many other sectors. Partners, look for a partner that is both easy to use, but also is extensible enough to the open source and the coding worlds. That's really important because you need a collaborative space for everybody in the organization to use, not some people using something, some people using something else. In terms of low code, Gartner have said that by 2024, over 65% of enterprise development activity will be low code. 75% of large enterprises will be using at least 4 low code development tools. The logos are just a selection of the many companies moving into this sort of data democratization world. Some are open source, some are commercial, all worth checking out. Culture, we've sort of touched on. It's so important, as you see from this graph. Again, it is the single biggest blocker to success with data democratization initiatives, building that mindset, moving people away from traditional sort of annual budgeting cycles, top-down decision-making. That's what we need to do. Databricks have said, though, that only 24% of organizations have managed to forge this data-driven culture. So we need a lot more. How you develop that, storytelling, have rewards, bring in external inspirational speakers, and communicate far and wide, internally and externally. This will build fans in the organization, inbound investment and interest and use cases that data scientists can play out. Leaders have a big role to play. They need to make budget explicit in the annual strategic plans, because when they do that, and all business users need to actually spend money on data science, then they're going to start coming to the data science teams to get them to help their citizen data scientists. I think Airbnb have a great example with their data university, where they've managed to train over 60,000 of their internal employees, again, with low-code solutions and success criteria in place. And DNB Bank in Norway, Aiko, spoke about her data science community internally on the podcast recently. So that really is how you build a citizen data scientist movement, how you get data democratization. It's through starting small, having the right change management processes in place, building the culture, building the skills through training, through enablement, having the right tools in place as well. And again, these are just some of the topics we spoke about in the podcast over the last 6 months or so, and you can check that out on altair.com/future says. So I hope you all learned something from this today. This movement is absolutely happening. It's very exciting, and it's great to collaborate with DeFi to bring it to the next generation.
Great. Thanks for that. Yeah, thanks a lot, Cian. I think the session was really amazing. Got to learn a lot myself personally, especially I think you have nicely summarized different discussions that you had with the different leaders out there. And with that, probably I'll ask you a few questions. I think so. There is this question on YouTube, like there is still lack of awareness about best data practices or collection strategies. How do you see it evolving over time? Do you think democratization still looks far-fetched, like 5-10 years? Yeah, maybe your thoughts on that.
Yeah. So as you sort of saw on the simulation slide, it's an evolution. It's not a revolution. You start on bite sizes and you sort of scale out. When do I think this is happening? This is happening right now. I mean, you saw Ford, you saw Rolls-Royce. Ford have trained 1,000, Rolls-Royce have trained 20,000. They are doing data democratization. They have engineers building machine learning models to do a whole range of different use cases. Nevertheless, in 5 years' time, it'll be a completely next generation. But this is happening today. And I also think this allows every organization to get involved, because it's not a new role that you're hiring. A citizen data scientist is generally a persona. It's somebody that already exists in the business. So no matter what size your company is, if you can identify these people, train them accordingly, you can start right away today, and you can start getting value and reduce that barrier to entry to starting it.
Totally. And the next question is, so this was asked in between, so those statistics look quite interesting. I'm just curious, do you see ready to use ML models across various use cases a way to go with mass AI adoption? And a follow-up question to that is also, synthetic data has been a way to go about getting quality data, or closely considered as real world data. Do you see it as a way to tackle data challenges that organizations are facing? Yeah.
So let me answer the second one, and then I might ask you to repeat the first one. Yeah. But the second one, synthetic data, absolutely. I think this is a really exciting way now that people can use simulation models to create more data based on existing data. And again, if you're looking at smaller companies, generally they might not have a huge amount of data. They might be limited in the tests they've done, in the rows and columns they have. But by simulating runs, they can create more data, dummy data that looks like the information they have, and build models based on that. And this closed loop of simulation and data science, the market sort of calls it hybrid artificial intelligence, is in its nascent days, but it is exciting and it is starting for sure.
Yeah. So coming back to the first question, right? Do you see ready to use ML models on various use cases a way to go with mass AI adoption? Is the question.
Absolutely. Absolutely. I mean, I think some of the suppliers or the partners that I showed those logos, 10 or 12 of them or so, all of them have a workspace type approach where you drag and drop your data first and foremost. You do your data preparation, your partitioning, and that's a good point. Some citizen data scientists at the start might not partition their data, and they might treat everything as the gospel truth, and that's where this data buddy or data translator needs to help. But they all have these tools that you can drag and drop, do your feature engineering, feature selection, and then run different models. And again, most now have AutoML. So I do see this as being the future, but I also would like to say that the expert data scientist needs to be able to come in and add a node to these workflows, so that it's not just graphical user interface, it's adding code. It's the difference between code-free and code-friendly.
Right. And there's a question on AI ethics. So it says there is little to no transparency about ML models, I believe, when it is used at large scale. do you see governments imposing regulations on usage of AI? Would love to know your thoughts on if there is something that exists on those lines.
For sure. So governments all around the world are considering regulation of artificial intelligence right now, today. Many have released guidelines on ethical principles. The European Union were the very first in April of this year to actually release draft legislation on the governance of AI. What they have done is divide AI applications into 4 areas: minimal risk, low risk, transparency risk, and high risk. The minimal to no risk, they're the vast majority of AI applications today. And there's no regulation on it because you don't want to stifle innovation. The low risk, there are some questionnaires people need to fill out. There are ongoing audit checks they need to do if they're building models in, let's say, sensitive areas like healthcare or like banking, if you're saying yes or no to somebody for a loan, for a mortgage. Transparency is that with chatbots, with automated voice controllers, the human always needs to know if they're speaking to a person or a machine. And finally, the unacceptable risk, that is when there's only 4 applications, I think, where you're not allowed to use it all in the EU at the moment. Social scoring, it's manipulative AI, and then there's another 2 as well. So that's the very first legislation, but everybody is following suit. And yes, we need innovation, we need ethics. We also need to tread a careful line not to stifle innovation with it.
Got it. And we have another question. So this was from one of the slides that you mentioned, according to Ming Tang. Does it mean that every clinician has to be machine learning acquainted? This is a question.
I think everybody in the world in the future needs to be machine learning acquainted. So clinicians, absolutely. Engineers, absolutely. HR people, yeah. And I don't mean they're going to be enabled tomorrow, but they're NHS themselves, they've started that process, and every company needs to start. So I do think everybody needs to be acquainted.
Right. And there's another question, I think. It says responsible AI is, so basically the last step should be indeed of expert decision and not directly of AI. AI should potentially help experts and should not be the sole decision maker. This is something that's written by one of the viewer, and there's a follow-up question by the same person. It says responsible AI in sensitive fields, especially in health, is very important. Any insight on how organizations are handling transparency and strict guideline on use of AI in the field of healthcare sector?
Yeah. So what I would recommend whoever asked that question to check out is the NHS, which again is the health service in the UK. They have a big contest at the moment called the Analyst X Machine Learning Challenge. And you can do submissions. There's a range of challenges between now and the end of the year. But what they are doing is that with every submission, with every model produced, you need to produce a documentation of the model, the results of the model, what you did with the model. So there has to be extreme transparency, extreme explainability. But also, if you think from a healthcare context, there's always been ethics. I mean, doctors don't say to other doctors, don't say to other patients what someone is or is not sick with. So that's something healthcare as a sector has actually grown up with. So I would say they're potentially even more advanced in having ethics at the forefront and transparency at the forefront of the models they build.
Got it, Alain. And there's a follow-up question to the first question. So the ready-to-use AI models, ML models rather. So it is being referred to something like AWS machine learning marketplace, where a company develops a model and it being used by several other companies for a particular use case. So what's your perspective on machine learning model marketplaces in general?
I think they're awesome.
Like plug and play ML, maybe. Yeah.
Yeah, I think they're awesome. I think that goes to the slide about what do we need to democratize, and services and marketplaces is something we need to. So Azure, AWS, even Kaggle, these guys are doing a hugely important thing, and we need to do more. We need to have more of these marketplaces.
Yeah, sure. And then someone is asking if the slides can be shared, probably like, maybe, yeah.
Sure.
And yeah, but before that, before we sign off for the session, I have a one question myself. So how about, like, if you don't mind, can you walk us through your personal journey on how you transitioned from a business role to a data science role, and where did this love for data science came from in your personal journey? I'm sure, like, it will be very insightful for the people, and it will serve as inspiration for many more out there.
Yeah, for sure. Yeah. So again, similar to what I've sort of said, I consider myself a business person that is trying to be more and more data savvy, and what my role has evolved from is from being a business person, as you say, that is trying to lead software implementation projects, but from a high level, to now my role is working with a lot of our engineers to enable them on data science tools, so they can go, and when they're doing projects, when they're simulating the design of a car, for instance, they can now start to use a machine learning model to reduce some of the steps that they can do. And so my process has been from business, just dipping my feet in, but trying to do a lot of research, trying to read all the time, trying to speak to as many people as possible, speak to experts, like a lot of the quotations I've had, read a lot of books on data science, and gradually build up a knowledge and excitement of what is happening and what's going to happen in the future. And personally, I'm never going to leave this space now. I just love it so much, and it is so exciting. So I can't recommend it enough, really.
Yeah, glad to know that, and thanks for sharing the journey. And yeah, more power and more strength to you, and continue to make a difference, and continuing future says. I'm sure, like, a lot more inspiring leaders will come in and share more insights out there. And for those, like, who would want to follow Cian, will share Cian's LinkedIn, and I think he has already shared his email address and others. Thanks a lot to everyone for joining in, and thanks a ton to Cian for joining us and making this happen. Thanks a lot. Yeah. Bye.
Thanks, everybody. Have a nice day.